This conference will now be recorded. This conference will now be recorded.
Hello, friends. Good morning. Can you all hear me?
Yes.
Yeah,
Yes.
Great. Okay. So since this is demo, we are not going to do any introduction of you all. Uh, Let me share my screen. Give me a second. All right. Yeah. Welcome, everyone. Can you see my screen now?
yes.
Yes.
Just- All right. Okay. So before we proceed, let me introduce myself. My name is Kiran Kumar. You may call me Kiran. I have 10 plus years in IT industry and 7 years as DevOps and SRE. Previously, I worked with a global MNC. Now I'm working as a senior DevOps engineer. I also lead my team from India. Yeah, as I said, I'm working as a site reliability engineer uh, in a startup. Uh, I love technology in general, open source technologies in particular, and also I love, excuse me, love training folks on technology. I've given several trainings internally in my organizations and also to people like you in some institutes. So that's about me. Uh, so before we proceed to the course, you all might have received some information about what we are going to cover in this course and the course content. So, but I'll also brief you about what we are going to touch in this course. So, as the name says, it's a custom course built with content from Azure Cloud and also the DevOps toolchain. So we will work on Azure primarily, uh, but our aim is to learn the DevOps tools to understand how we automate services, how we do continuous integration and continuous delivery on Azure. So we will cover some of the Azure services. We'll cover some of the um, automation technologies and CI/CD technologies. So before we proceed, I think this audience might have a good understanding of what cloud is. However, let me just give you an overview. So what's cloud? So cloud in the sense of cloud computing means on-demand availability of computing resources without the direct active management by the user. In other words, cloud is a collection of data centers managed by a cloud provider, and users can rent resources on a pay as you go model without the front cost. So cloud is nothing but data centers or rather computing resources available for any user to rent. So this does not involve talking to someone from the cloud provider. You will be given a console like a website or a command line, and you can interact with the uh, cloud programmatically or through your web service and create resources. And you could also create and delete your resources without actual user intervention from the cloud provider side. So to give you a real life analogy, um, let's say, just a second. So let's take an example of a warehouse or or what we call a godown. So why do we need a cloud and what is its advantage? For example, suppose you are into data or you are into some retail business, and you have a warehouse or a godown like which is filled up to, let's say, only 40% most of the year. Okay. And let's say from Jan to, excuse me, from Jan to Feb or Jan to April, maybe you'll need 60% of space. Okay, so suppose this is your actual utilization all through the year, but only in your business season you might need this additional space. Okay, but you're still wasting your 40% of space, and also throughout the year you're wasting this additional 20% of space. So if you compare this to a data center or your any organization's IT setup. Let's suppose if they are using only like 30 servers all through the year, and in their peak period, maybe they are into tax business and they have like they peak up to 50% or they peak up to 70%. But before the tax season, they have to get all the servers ready. They have to have cooling for all these things. They have to have power backups and everything. So cloud takes care of this business. So it's if you want to use only 20% for when you begin, you can pay only for 20% and you don't have to pay for all this. And if you want to expand to, like, say, um, if you want to expand to some double your business, current business, so you had 20 servers and you need to expand to 40 servers, you can expand without actually paying any upfront cost. In the sense, you need not pay for the services before you start using them. You can start using them. Yeah, you can start using them and pay only when you start using, and per month billing or per yearly billing as per your contract. So this will take away the useless utilization on billing for your other resources which are lying idle for the most of the year. So this is what we call elasticity, to scale up and scale down without actually uh, paying for the entire resources you use, or paying for the highest resources you use, although all through the year they lie unused. Okay, so that's the real life analogy about cloud, and that's why IT organizations have been adapting cloud very quickly. So anyone has any question on this part? Okay, I'll take that as a no. And next, yeah, as this course is obviously about Azure, let's talk what is Azure. So Azure is the Microsoft's cloud offering. So it's definitely the leading cloud providers, only behind AWS in the market share and service offerings. I mean, if you take the total market share or even the uh, number of services offered, uh, Azure is the second most leading cloud provider today in the market. And yeah, Azure has its infrastructure spread across globe in 54 regions and 140 countries. And they have services right from virtual machines to storage. You have machine learning tools, IoT, big data, and security, and many others, which you can rent as you go, and just decommission or delete them as you're done. All right. So that's about Azure. And just a small note, Azure is Microsoft's cloud offering. Azure has Microsoft has another product called Azure DevOps. Okay, so the name itself is Azure DevOps. That is in actually you could call a DevOps tool chain for offered from Microsoft. It has its own CI/CD tools. It has its own ticketing system and a Kanban board and its own source code repository. We are going to touch that, but this course is going to be more about Azure services rather than Azure DevOps. That's the reason we put the course name as Azure plus DevOps and not Azure DevOps. Hope you guys are clear with that. Or do you want me to repeat? Hello?
Yeah, actually, like, are you going to conduct to teach about only the Azure DevOps or separate Azure and separate DevOps?
So as I said, we are going to do everything on Azure. Okay. So if you want to practice, let's say, if you want to practice, let's say, Linux commands, we are going to create a resource on Azure. Okay, so if you want to practice how CI/CD works in real life, so we are going to create resources in Azure and use other DevOps tools to understand how it's done. Okay, so it covers a bit of Azure services, primarily the infrastructure services, and also it covers some of the DevOps technologies. I have a detailed slide which will give you all the details about what's covered. Okay.
Okay, okay.
Yeah, but the
Yeah,
point was
okay.
about Azure DevOps. It's not going to be entirely about the tool called Azure DevOps. It's mostly the Azure cloud. Okay.
Okay, okay.
Yeah, thanks.
Okay.
So yeah, what are we going to cover in this course? So this is like a high level breakup, and if you want even further details, we have a PDF document that will be shared with all of you. Okay, so within the Azure services, we are going to cover identity and access management, how networking works, Azure virtual machines, and Azure storage. There are different types of storages. We are going to cover some of them, and how can you monitor resources on your Azure. Okay, and we all, since Linux is the most or GNU Linux is the most widely used operating system for enterprise ITs these days. So we're going to touch some Linux administration. We are going to talk about Linux system overview, how the file structure looks. Because if you're coming from a Windows background, you might not know how the file structure and how you navigate between different directories. We talk about how process management works in Linux, the package management, a bit of networking, and how you do the disk management. And DevOps. And DevOps, we'll cover what and why, like what is DevOps and why do we need DevOps? And we will cover the toolchain overview, like what are the various tools we are going to cover. Because if you look at DevOps toolchain today, this has a various tools related to each of the components. Okay, uh, so let's say this is one of the pictures that shows the amount of DevOps tools we have today, right from your documentation in terms of Confluence. We have ticketing systems, we have version control, uh, we have the containers, we have the cloud. Here we are talking about Azure though, the software control management, and various other tools. So we are going to touch some of them. Okay. So we'll have an overview of it, and we'll talk about version control, since the DevOps teams also are responsible to manage their code within a version control, and also responsible to managing the uh, GitHub repositories or GitLab repositories for the developers. We'll talk about version control and source code management, and then this is the product I was talking about. The name itself is Azure DevOps. Okay, sorry. So the name of the product itself is Azure DevOps, which give you so it has its own source code management, meaning it has its own GitHub sort of thing. It has its own CI/CD pipeline. Instead of Jenkins, you can use their own CI/CD pipeline, and they have their own project management tools like your Kanban board. Okay, or you could call that equivalent to Jira. Okay, and when it comes to containers, you know that Docker is the predominant um, containers choice today. And then Kubernetes, which is an orchestration tool for your Docker or your containers rather. So, and we also talk about the managed service called Azure Kubernetes Service. So Azure Kubernetes Service is the managed service provided by Azure, where you can deploy Kubernetes services. We'll talk about that. Okay, so this is very high level, and each of them will have very many subcomponents within them, and we're going to talk a lot about in detail. In, for example, networking, you'll talk about virtual networks, subnets. How do you divide into various subnets using your CIDR blocks? So we'll cover a generic networking as well, not only related to Azure. And when it comes to Azure virtual machines, we discuss how uh, how the machines are provisioned, and how do we understand the availability zones, regions, and various other things come up. So this is very high level overview. So the Azure services might seem very small component, but we have a lot to cover in that. And also we're going to maybe discuss a real-time scenario, how you deploy an application in Azure, maybe using Azure DevOps. And we'll actually, yeah, within the DevOps, we'll also have our own infrastructure as a code tool. We will discuss a bit of Terraform and also ARM template, which will be part of automation. I somehow missed it. Yeah, so we still have automation section where we cover ARM templates, that is Azure Resource Manager templates, where you can automate creation of resources. We'll also cover Azure command line. We will also cover Terraform. Terraform is another tool for infrastructure automation, meaning you could create and delete resources on cloud with code. Okay. Yeah, that those are the overall tools. Maybe we would cover some software configuration management using Ansible. Sorry, I missed the automation section, so that's the reason. Yeah, let me write it down for you guys. So in the automation section, we're going to cover Azure Resource Manager templates, which is nothing but ARM template. Okay, we're going to cover Azure CLI. How do you manage resources from your command line? How do you organize your profiles from Azure CLI? And we're going to talk about Terraform. We'll do some software configuration with Ansible. How do you install? Ansible is a software configuration management tool. We'll talk about in a minute. What software configuration management does is to manage multiple services, servers at once. So an organization might have, let's say, 100 servers, or just 100 servers for one region. Like their Americas region might need just 100 servers for one region. So Ansible takes care of deploying software. For example, if there are 50 web servers and all of them need, let's say, Apache or Nginx, so Ansible will automate the installation of web servers on all these servers without actually logging into each of these servers. Okay, that's the software configuration part. Okay, so that's what will be covered in this course on a high level view. Do you have any questions regarding this? Definitely, this is the important bit of today's demo. Any questions?
No.
Okay, cool.
So I'm interesting. Tell about yourself.
Yeah, my name is Kiran. I have 12 years experience in IT and been working in DevOps from past 7 years. I worked as a senior DevOps engineer in an MNC previously. Now working in a AI ML based startup, machine learning based startup. I lead the DevOps team here from India. We have a team in Austin as well. Yeah, that's about me precisely.
Yeah, that's great actually. And
Yeah.
after completing this course, like let's
Mhm.
say, like I'm basically from, I can say, WebLogic background.
Mhm.
And, like apart from this, do I need to prepare anything else for the jobs? Like if I want to attend any job
So as
interview.
you know, yeah. So as you know, technology is both very wide and deep. So there are several bits, and this course will be your primer and also an in-depth introduction to not introduction, rather in-depth. We will also do some hands-on, so in-depth hands-on on many of the tools. However, you would need to practice all through this session. Like our class might be for 1 hour, 1 hour 15 minutes, but post the class you need to practice so that you get the real hang of it. And also maybe you should continue to practice till you get the, I mean, when you're in the process of taking calls for the interviews, you need to be on your toes, like learn. uh, so uh, I could say that you just need to to keep yourself updated and be ready. So yeah, this course will be a very good starting point for you. This could be called as a launch pad, but I would suggest everyone that you would need to continuously practice, not only throughout this course but also after this course, so that so you need to give, for example, you're working from a WebLogic background, right? Sorry, what's your name?
Raja.
Raja, yeah, you're working from a WebLogic background. So the way you need to justify this is as if you've already worked in the production on DevOps, right? So that's that you could give only you have enough practice on these tools. Okay, so that's my point. So this class will be your launch pad. You'll need to practice, and then definitely you could convince your interviewer that you've already worked on the production systems on Azure. Okay.
Okay.
Yeah. Anyone else has any question?
Hi, I have one question
Yeah.
regarding for which I mean, which Microsoft technology you prefer to take as a CI/CD, or I mean, which web application or Windows application, or which technology you prefer for that, like Java or .NET?
So yeah, we are not going to do much of the configuration from the software side. All that we need to do is, install the right build tool on your build server. So we are going with the Java applications because these are freely available online. Some of my friends could also help me with some code. So yeah, we are going with Java. Yeah. Um okay. So before we proceed, let's talk about DevOps. What is Agile and what is DevOps? You might have heard these words. Agile and DevOps, sometimes interchangeably, sometimes as a different models. So to understand DevOps and why it's needed, we need to have some understanding of Agile model of software development. And as you know, Agile is a software development methodology. But before that, what is this software development? Software development, like any other systems, has its own what do you call models. So let's talk about SDLC, or the software development lifecycle. This is actually the process of uh, building the software. So software development lifecycle is the process used by IT organizations to plan, design, implement, maintain, test, and deploy software applications. So the SDLC aims to produce a high quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. So the software development lifecycle plan is to, uh, you know, from the ground zero, you gather your requirements from the client. What kind of application is the what kind of the solution is the customer looking for, and what are the various technologies you would require. That's the design part. You design your application. Okay, maybe I'll design it as a n-tier application or a 3-tier application, and I will use these technologies for web server, these for middleware, and these for the database. And how do you implement this? Where do you implement this? Do you want to implement in the customer's data center or a public cloud, or you in your own data center? And yeah, how do you deploy the code? This is the implementation part. And once the production when the application is go live, you need to maintain that part, and you need to test continuously whenever you do a release, and also deploy software updates. Okay, this entire cycle together is called as software development life cycle. So before we go to Agile, there was another model of development which was called Waterfall. uh, okay, so this is basically the software development life cycle. You have planning, you define things like what all we need, then you design how do we integrate all of them. You actually start building the infrastructure and deploying the code, and also testing, and then you do again. It's a continuous cycle of deploying new updates and stuff. Okay, so the traditional approach. So far IT organizations have, not so far, but let's say, mm, till a decade ago or even 15 years ago, most of the approach was called waterfall. So the waterfall model is a breakdown of project activities in linear sequential phases. So it's like a continuous line. You can go to the next step only if you complete this current step. Okay, so that's what it says. Each phase depends on the deliverables of the previous one, and corresponds to a specialization of tasks. So each phase has its own specialized list of tasks. This is typical for certain areas of engineering design, meaning this is common for some engineering designs. In software development, it tends to be among the less iterative and flexible approaches. So it was not very flexible, as I said, because you cannot go to the next step till you complete this step. Okay, so that means you have a dependency and you cannot proceed to the next approach, even though you could do that in software. So it's called as unidirectional or one direction. It's always downwards. That's why you call it as a waterfall. So through the phases of conception, that is your planning, initiation, analysis, design, construction, testing, deployment, and maintenance. So if you look at a picture, this is how waterfall looks like. First you gather requires, you design, you implement, you verify, that is your testing, then you keep on maintaining. So one of the shortcomings of this model is, for example, you've reached the design model and your customer says, hey, I need some more changes in my application. Then the traditional method, that's the waterfall method, tells you, hey, wait, we have to implement this solution, we have to verify, we have to maintain. Only then we can gather for the only then we can come for new requirements, and then we can proceed to the design and through implementation and verification and maintenance. So this is very rigid. So every time there is a requirement change, you will need to wait for a full cycle to complete. So given this, and software requirements keep changing, users requirements keep changing every now and then. So keeping this in mind, a new methodology has come in place. It's called Agile. The very word Agile means uh, to be able to move quickly, right? You might have heard about being agile, sports persons being agile. So the term Agile means the ability to move quickly with grace. That means it's not as if you're fumbling, but you move quite well. That's the term Agile. So in the area of software development, Agile methodology comprises various approaches to software development, like how to gather requirements, how to work in teams, and how to organize teams, and how to create these cross-functional teams, in the sense development is one function, QA is one function, and let's say operations is another function. How do you create a uh, unit? They might sit separately still, but you still call it as one unit for your project. So that's the Agile approach. So Agile advocates adaptive planning, meaning the planning could be adapted anytime to the new requirements, and evolutionary development, and early delivery, and continual improvement. So you deliver the product early, and upon that you keep on adding new features. So let's suppose today we have an app called a very popular social media app, WhatsApp, right? And we have various features in WhatsApp today. For example, you can swipe to reply, you can get previews of images in your notifications itself. Suppose WhatsApp waited all this long, meaning 2019, so that they could launch an app with all these features, instead of, if you remember WhatsApp in the early stages, there were no features like this, right? Like swipe to reply, or notifications previews, or replying from the notifications area. You're all familiar with these right now. So whereas in the back in the day, you cannot do any of these. You could not do any of this. You need to just go into the app, type there, and there is no reply to the message feature and all this. Suppose WhatsApp waited to develop all these features and release the product as it is in 2019 instead of say 2012. It could have been overrun by competition, meaning Telegram, Hike, and whatever other applications could have been dominant. But what WhatsApp did is, whatever it has its minimal features, it released early. Okay, and upon that, it kept on adding new features, right? It kept on adding features like swipe to reply. It kept on adding replies like audio messages. Now later it added calls. So this is what we call continual improvement. So instead of doing a big bang release, like release take the take a decade to develop the entire product and then release, that's the big bang approach. But this is the continual approach, where you release your product with the minimum features that the market is looking for, and upon that you keep on improving. So that's the Agile method of software development, instead of releasing everything at once. So that has brought a significant change in the software development industry. If you see today, earlier in the days, people who might have used XP or Windows 7 or even previous versions of operating system, we would get updates like very rarely, like once in a quarter or sometimes once in half a year. But if you see, we keep getting updates very frequently. Even in your Android app, every now and then you get updates for each and every other apps that you install. That's made possible through this agile approach, because you could release early the product and you could keep on building the new features. So if you compare the agile versus waterfall, so this is the waterfall approach, as I said. So once you analyze, you got into plan phase, you cannot go back to analyze. Okay, or rather you could only continue forward. In the agile methodology, once you analyze and you plan, you start designing, you can build, test, and maybe if required you could replan. Okay, and again deploy it, again analyze, do the analysis again. Is my product meeting the customer requirements? Is it meeting the load performance requirements? Okay, so then again you could plan, you could design, you can build and test and deploy. So this is how agile is different from the traditional method of waterfall, and this is what makes the software development very agile in the true sense, and you could keep on building new features. Okay, that's the waterfall versus agile method. Any questions? Okay, so you heard about agile. Now what is DevOps? Okay, so DevOps is again one of the important characteristics of an agile development team is to work in small teams. Again, coordinate better with all the what do you cross-functional teams. So DevOps also aims to do that. It aims to break the silos between the dev and operations. Maybe you could also say QA, which is anytime considered as a part of development. So it breaks those barriers between development and operations. So what would happen earlier, if many of you, some of you have worked in the IT organizations in a application management role or platform role. So you would know that earlier the operations team would know about a product release only when it has, across many stages, like the planning is done, the analysis is done, they have built the application. Okay, and the operations team would be informed only when they need to deploy the application in, let's say, their staging environment or pre-production environment, and then on the production environment. Before that, they are in complete darkness about what is happening in the development side. So DevOps practice aims to break these barriers and bring these teams together, and work with them from the day zero itself. So when a new software project comes up, the actual DevOps approach is to involve both the operations side and the development side, and uh, talk about the planning, how we are going to implement, and everything. So that's one of the key characteristics of DevOps. So DevOps is a set of software development practices that combine software development and information technology operations, that is IT operations, to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in a close alignment with business objectives. This is what Wikipedia says. So what it says is, you bring together the development and operations team. The main motto is to shorten the systems development lifecycle. That means you need to release the product as soon as you can, in a very short time, but you should also be able to deliver new features and fixes and updates very frequently, and these should be in alignment with your business objectives, not just because you like the feature, but does your business really require that feature? That is what meaning by close alignment with business objectives. Okay, so I found some of the you know definitions given by some of the folks out there. So DevOps is a methodology that combines software development with operations. The intent is to enable communication between the teams so that they can build, test, and release software more quickly and with greater efficiency and speed. So this is where the DevOps really comes into picture. To be able to build, test, and release software more quickly and with greater efficiency and speed. So when you say efficiency, is to have very minimal bugs. Okay, and to speed is to deliver in regular intervals, like every quarter or every month you have a new update, new feature, or you fix bugs quickly. Okay, that's the main intent of DevOps. So DevOps and Agile complement each other. They're not like a separate practices. While Agile focuses on uh, effective software development, the DevOps intent is to bring this uh, take this code to the customer quickly as possible, and to enable the developers to test their code, to build them, and also do the automation process when you require your infrastructure. Okay, so one of the important components for DevOps is also this infrastructure automation, where you need to create tools where, let's say, the infrastructure is created within a few minutes, or uh, yeah, within an hour, unlike the traditional approach. So you need to have those tools which will enable the developers to test the software or build their software very quickly. That's the main intent of DevOps. Okay, so any questions so far on Agile or DevOps or anything? Okay, I'll take that as a no. Right, again, theoretically speaking, DevOps is not a role. So there's a book by Google called Site Reliability Engineering. There it clearly says DevOps is not a role like your QA engineer or your uh, software development engineer. It's simply a practice. Okay, it's a culture that aims to create better coordination between development, QA, and operations, and speed up software release with utmost quality, with the best quality. However, in practice, in real world, we'll see job roles that are called DevOps engineer. You might see openings in Naukri, uh, LinkedIn, everywhere that they have opening for DevOps engineers, and there are still teams called DevOps. So that's the practice, right? There is always this gap between theory and practice. And what is the primary aim? As I already said, it's about releasing software quickly and maintain applications with high availability and resilience. So when you release your software, they also need to be built on software, built on infrastructure that is quite resilient, meaning when there are failures, you could recover quickly from the failure, and that's called the mean time to recover in the ITSM language. And resilience is again, yeah, the same thing. So high availability is, even if one of your components is down, your total application, or there should be only a minimal impact on the application. So that's how you create high available applications. So the DevOps jobs is to create these tools that could create highly available and resilient uh, software systems. Okay, so if you I mean, this is from my perspective. There might be a different perspective altogether on what comprises DevOps components. Okay, so I said I've been so far saying DevOps is a practice, DevOps is a practice, but actually DevOps is not just about culture and a practice. It's also about the people, the right set of people, and also the right set of tool chain, the right set of tools. So as I said, if you could take the operation side of the IT industry, you could I mean, I could think of these four main things for from the DevOps side. Like you have to take care of your infrastructure, whether it's your private data center or public cloud. You have to take care of installing software. When I say installing software, installing your Apache server, your code is built by your developers, but you need to have some tools to run that code, right? For example, someone works on WebLogic, that needs to be installed on the servers. Also, you might need to do some tweaks on the servers, like opening this port, or doing some security hardening. That's part of software configuration. Then when the developers build software, it's all text files, right? It's plain text when developers start writing code, but that needs to be built into an executable, like a .exe, like a .apk if it's a mobile app, or .var, .zar for a jar for a Java application. Then you need to release the application onto your environments, QA, stage, and later into production. Then once your application is live in production, you're not done. You need to continuously monitor those systems. Okay, you need to continuously see if any of these services is going down, if any of the applications is going down. And no one can sit in front of their system and monitor. You also need to have an alerting mechanism, meaning the systems monitor the other system. I mean, the monitoring system monitors your web application or your databases, and they will alert you through another system. So as I said, we have various technologies for each. So when I say infrastructure, uh, infrastructure is the component that needs to be taken care. But what do you need to do with the infrastructure? You need to automate it. So there's a concept called as infrastructure as code, meaning just like your software development, you keep the infrastructure elements as a piece of code. Like you will have a simple document that says uh, 4 web servers, with 2 CPUs and 6 GB RAM each. So but you have a simple file, and the file itself will create the infrastructure. Okay. So we'll come to that later. But just to give you a overview how it works, uh, the IAC tool. Okay. Yeah. That's it. So simply by defining your infrastructure in this form, okay, this will be your setup. This will decide what components need to be this will actually describe what components are being created, and you simply deploy this file. You just there's a command called terraform apply, and all that is defined in this. For example, what is the network, everything is created from this. So that's what infrastructure as a code means. Meaning you maintain your code in the form of you maintain your infrastructure in the form of a code rather than an inventory. So you simply apply the code and you create the infrastructure on a cloud or on your private data center. Or you could also easily destroy the same using the infrastructure as code tools. Some of the examples for infrastructure as code, right now I've shown you Terraform. CloudFormation is again an AWS specific tool. ARM templates are specific to Azure. So Terraform is like cloud neutral or provider neutral. You can use it for multiple vendors, including VMware, uh, Kubernetes, Google Cloud Platform, Azure, and all this stuff. So software configuration, there are various tools. Primarily popular right now is Ansible. We have Chef. We have Puppet. These tools enable you to configure software on your machines. So suppose, as I said, your application has 5 web servers and let's say 5 database servers. So you need to install 5 Apache on 5 of these instances and MySQL on 5 of these instances. So Ansible is also similar to Ansible, or any of these tools is also similar to your Terraform or CloudFormation, where you can define all this in a simple file and you apply, and all these changes are applied onto your systems. Of course, we need to do some prerequisites before that. So that's the software configuration. Again, as I said, build, everything is built in the form of a text file first, and you need to compile it into a executable file. So you have Ant, Maven, you get Make. You could also consider Jenkins here, because Jenkins, or even your Azure DevOps, they have their inbuilt tools. Then you need to create a system where the deployment is automatic, meaning once you build the tool, you earlier traditional approach was to copy the exe or the jar file and put it in your Tomcat or Apache server, or even in your IIS servers. Right now you need to build an automated way, so that once the build is done, you take this build and deploy it on your servers. That's the release part, the continuous deployment part. Monitoring, again, we'll talk about Azure Monitor in this course. Sorry. Okay, we'll talk about Azure Monitor, how it works, how we can monitor resources using that. Okay, maybe we could touch a bit of PagerDuty on alerting. PagerDuty is one of the very popular alerting mechanisms, monitoring and alerting mechanisms. Okay, and if you see the release and build part, again, this has to be or in fact, any of these things have to be maintained in the form of a source code. So we will also cover the source code management, which I touched upon as version control and source code management. So we'll talk about version control, how Git works. Okay, how you can use Git with GitHub, and also how you can use Git with your own Azure DevOps installation. Okay, that's also there. So yeah, any questions so far?
Where is the Docker and Kubernetes is going to fit here?
Yeah, I did not put it here, but you could say it's part of your you know build and release or even your infrastructure part. So we will definitely touch the Docker and Kubernetes part.
Hello.
Yeah.
Hello. Yeah. What are the requirements to jump into DevOps as a layman? Like, what are the
So ideally, it would be very good if you have a bit of Linux administration and understanding of how applications work. Okay, so how what are the various components in an application? Meaning, uh, let's talk about Facebook.com. You need not know exactly what Facebook is doing. Maybe you should have an understanding of uh, what a load balancer is, what a firewall is. Okay, what's a web server, the three-tier component. If you have that, that would be very good. Even if you don't have it, I will definitely try to break it from the beginning, like take it in small chunks and talk about how the applications work in real world and how we can apply to them. Okay, I would say all that you need is a nice appetite, hunger for learning. Okay,
if we don't have
sorry, what's your name?
Chiranjeevi.
Your voice is breaking.
Yeah, this is Chiranjeevi.
Okay, Chiranjeevi, yeah.
So,
So
like,
we have,
have what
go ahead.
Linux skills. So, what we need to do, like,
So as I said, most of the applications today are deployed on Linux. Okay, so you need to understand how do we SSH into a server, or rather remotely access the remote server and check what's happening on that. Okay, you might need to configure Ansible on a Linux server so that you could deploy code onto multiple machines. So all this is done on a Linux server. So you need to understand how you install packages, how you manage processes, how do you edit files. Okay, so those things we will cover. Does it make sense? Is it clear?
yeah,
Okay, yeah. So everything is, I mean, I would say that's the right choice to do your automation, because Linux has such flexibility and less overhead. Okay. Uh, yeah. Any other questions?
Kiran, sorry to interrupt you.
Hmm.
Hi all, this is Lakshmi from Career IT. Small info from my end. The batch will be starting from Monday onwards. Timings are from 7 to 8 a.m. IST. For more details, you can reach us on the numbers and whatever I provided in chat. Thank you. Yeah, please you can carry on, Kiran. Thank you.
Yeah. So again, more on DevOps. So if you're looking for the jobs, some of the roles that are similar to DevOps are site reliability engineering and also the cloud ops engineer. And let me tell you, these jobs are not universal or uniform across the organizations. For example, some organization might say they are doing DevOps, but they might only do build and release. They might not do the infrastructure automation part. Okay, some organizations might do entire, like they might have SRE team which does everything. Okay, there are some teams which are called cloud ops. They're only responsible to manage stuff on the cloud. Like they'll give you access to their Azure portal. You need to manage resources for them. You need to manage access to them. So it varies. For example, in our organizations we do everything, right from it was earlier into two separate teams. Build and release was taken care by DevOps, and tooling was done by the DevOps. We were responsible primarily for deploying and managing the applications. Right now we are doing everything together, like right from CI/CD to everything. Okay, but what is the important trait, or what is the important characteristic of a DevOps or an SRE is the ability to automate repetitive tasks and minimize human intervention. For example, we talked about installing a web server or installing MariaDB or MySQL. So the intent is to have as less as human intervention as possible, meaning uh, just let the code do the work. Okay, so you need to create those automation for your development teams and the QA teams. Again, as I said, the roles and responsibility of a DevOps engineer might vary from organization to organization. The tool set, or what we call as technology stack, could also vary, meaning Some organizations might use Ansible, some others might use Chef, some others might have their own automation using Python or Ruby or Perl. So it might vary, but what you need to have is that right approach and right understanding of how the enterprise IT works. Okay, so some of these are essential for anyone, like your Linux operating system, uh, and understanding of how the software configuration works, and the various authentication mechanism like SSH keys and stuff like that. So these are like and even your version control. Some organization might use GitLab, some organizations might use Azure DevOps, organizations might use GitHub, some might use Bitbucket. But the underlying version control today, which is very popular, is Git. So the Git you should all know well. Okay, so that's my 2 cents on DevOps. So to sum it up, cloud gives the organizations the ability to provision or decommission resources in a matter of few minutes. And DevOps, again, as I said, is a combination of people, culture, and tools that aim to make software delivery faster and efficient while maintaining high level of code quality and security. When organizations adopt DevOps practices along with they get most of their investment with frequent and quality software releases, and also able to build high available, fault tolerant, and resilient systems. We did not touch much on cloud. Maybe we'll start from Monday, but as I said, cloud will give you that ability to scale up soon and also scale down soon. That's what I wanted to say here. So the reason I'm saying this is more and more organizations are adapting cloud. Okay, not as fast as we thought they would, but still many organizations are adopting cloud sooner, and most of them is on IaaS market, infrastructure as a service side. So again, to be effective as a DevOps practitioner, one needs to not only have a thorough knowledge and tools, but also understand the SDLC, the IT operations part, and also automating the repetitive tasks. I already told these things, and creating repeatable and modular tools, meaning if you create one script today using Terraform, and if I give it to anyone else in the organization with minor changes, they need to also build their own applications. Okay, that is what is meaning by what I mean by repeatable and modular tools. So this aim covers to cover the key services in Azure from the DevOps perspective, and also the prominent DevOps tools in the market today, which will give you the right skills to add to your resume, and you will become a the top-notch candidate for DevOps. But as I said again, there is only like the 25%, 50% contribution from my end as a teacher. It all depends upon how you practice and how you implement. And another important aspect when you prepare for a DevOps interview is communication. Like for any interview, communication is important. Suppose you learned everything, you could do single click deployments after this course. I mean, you practiced very well, but what's the point if you cannot explain to the interviewer what you do when there is a business case? So the communication side is also something, as someone has asked earlier, what are the other prerequisites? Yeah, as I said, your approach to learn, your curiosity, and also you need to build on your communications. I think most of the folks today are already working somewhere, I guess, this session. So sessions attend sorry people who attended this session, so you should be already familiar with you should already be good with communication and how you can document stuff and how you can attend interviews. So that should not be a major challenge, but giving quality time to practice is very important. So yeah, that's about it from my end for the demo. I'm open for questions now.
So for practice, are you providing any lab or something like, or how you'll
Just give me a
practice?
second. Just give me a second. Yeah, that's a very good question. Azure gives us all a free tier subscription for 1 month, where you could, I mean, you cannot create anything and everything within this 1 month, but it has some limitations. But that would be good enough for us to uh, create resources. So that's the advantage with cloud. Today, most of the cloud providers give you a free trial, and you can try that for 1 month. Okay. And also you could get a free subscription on Azure DevOps, which is another tool. You could practice on that. You could maybe, if you want to practice, you could create your own GitHub, which is better than Azure DevOps. Yeah, these are some of the prerequisites. You all need to have a laptop. That's a good point he brought up. So you all need to have a laptop with good internet connection. You should have the admin rights, meaning you should be able to install some tools. You'll do most of the stuff on cloud, but even to access the cloud, maybe you'll need tools like a tools like Git Bash and stuff like that. Excuse me, just give me a second.
So I have one more question. Like, what is the difference between AWS DevOps and Azure DevOps in terms of functionality or in
So
terms?
from so from my perspective, there is nothing like AWS DevOps or Azure DevOps, unless you're talking about Azure DevOps as a tool. Okay, if you're talking about Azure Cloud and AWS Cloud, you could implement the same set of technologies like Terraform, Ansible on both Azure and AWS as well. Okay, so some of the technologies like Terraform or Ansible, these are cloud neutral or cloud agnostic, meaning you could use it both on AWS and Azure as well. But if you talk about some tools like ARM templates that we talked about, those are specific to Azure. Those are only useful for automating infrastructure on Azure. Similarly, CloudFormation is AWS's own, what do you say, own technology. Yeah, does that help? Or so let me break it again. Like DevOps is one set of tools, and your Azure is a cloud. Azure is like your infrastructure provide. So whatever Azure simply gives you the resources. You could do whatever you want to do on the uh, Azure cloud. So which tools you use is your organization's choice. Maybe they could use all open source tools. Maybe they could use all Microsoft tools. It depends. Same thing you could do with AWS. AWS also gives you some tools. You could use their tools, or you could, use the open source tools like Ansible and Terraform, which can be used on any cloud provider. Does it make sense, or did I confuse you? Hello? Hello? Sorry? Hello? Am I audible?
Yeah, you are audible.
Okay, yeah. Sorry, someone has a question, I guess. Can't hear you. Maybe you want to type. Okay, so what is CI/CD part? As I said, if you don't have any questions, please mute for now. Mute yourself for now. Okay. So initially, when software development teams began developing the software, it's all in the form of plain text files. Okay, so these needs to be built into executable files. For example, when WhatsApp builds their application, they write all it in the form of, maybe it's a Python language or Go language or PHP. So it's all plain text files. Okay, just like your C code or your DOS code. And once this code is written, we'll have to build it into the form of an executable. For example, in the form of an APK to be installed on your mobile phones. So there are some tools which will help you build this. So they'll take the code and they will create what we call as artifacts, or the installables like .exe files, .apk files. So, and every time the code is and multiple developers work on a same software project, so every time people commit their code to a source code repository, so they can't store all the data in a their local machine, right? All the code in the local machine, because other developers also need to see that and build upon it. So all this code is saved in a source code repository like a GitHub. Okay, so the process of continuous integration is to take this code that is being pushed there by developers and building it into the form of an executable. So what continuous integration aims to do is, earlier people used to make changes to the code, commit, but all of this code used to be integrated like once in a month. Okay, then you have something called as integration hell. Like a lot of developers contribute to the code and you integrate that together into one piece, but you might see a lot of errors and you don't know which part is causing the errors. Is it because of developer A, developer B, developer C? You don't know. But the continuous integration process aims to integrate this code as soon as possible. I mean, as many times as possible, so that every time a change is made and it is integrated into a new piece and tested, you know, oh, maybe it's because of the recent change done by developer B. That's why we are seeing the errors. Then you can rectify immediately and again commit the code. So that's the process of continuous integration. And once you build this installable, you need to test that. So to be able to test that, you need to deploy on some servers. So you do not deploy directly on your, what you say, production environment. Instead, you deploy in your QA environment or staging environment. So the process of setting this pipeline, after the build is done, you'll take the artifacts and deploy onto your servers, is the continuous delivery. This is also, you continue as soon as the build is deployed or build is done, you'll take the artifacts and deploy on your servers. This is the process of continuous delivery in a nutshell. Okay. Chiru, to your question again, I'm saying this: Azure DevOps is one product from Microsoft. Okay. Uh, Today we are discussing Azure plus DevOps, which means we are using DevOps tools on Azure cloud. Okay. So with Azure DevOps knowledge, can you go into AWS? Maybe yes. If you also, there is nothing like AWS DevOps again. AWS is a cloud provider, and DevOps is about your organization. Whether your organization want to use DevOps or they want to use the traditional approach, it's their approach. Okay. So if you know the DevOps tools and if you know some bit of AWS, with this course also you could be hired by an AWS plus DevOps, AWS DevOps role.
Hello.
Yeah.
How we know developer A, developer B, developer C code? How we integrate?
So your GitHub or your software version control system will have the logs. Who did the last commit? Okay. So and
Okay.
after then you know what time your code is built. So if your code is broken because of the last commit, okay, because the code was built at 10:50 a.m., the last commit was done by so and so, or maybe you need to do some deep diving as well. There
Okay.
might be three developers who have developed in that same time. Okay, so then you could, but it's much easier than doing it at like for after 100 commits or 200 commits. That's the difference. You could narrow down to one or two developers
For
and
that
say,
we
okay,
need to
yeah, go ahead.
we have one more option, right? Pre-commit script. Git pre-commit script. Like we will create one script. We will give user as per that commit ID.
Okay.
Then we will easily understood, right? For because of bash script.
Yeah, I'm not really sure
A
what your question is.
pre-commit hook. You know, no? A pre-commit
Yeah,
hook.
yeah,
Yeah.
true. We can do
We
that.
will-
Yeah, we can do that. Yeah,
uh
definitely.
we yeah, that is okay. Yeah, go ahead.
Yeah, yeah. We don't require any basic code. I mean, it's good to have coding skills, definitely. But what we do is mostly on the on your, typing. You need a lot of typing. For example, we talked about Terraform, right? Terraform have their own language. It's not like you have it's in C or Python. In the background, it might be written in Python, but it has its own language for us to use. So you note it's not, it's good, but it's not mandatory that you have a coding knowledge. Okay, but if you understand how looping works, how if loops works, that helps. We'll touch a bit of Bash scripting, scripting using Linux, but yeah, that should be fine. It's definitely helpful if you have some scripting language or coding skills, but not mandatory. Again, PowerShell. I talked about Azure CLI, right? Azure CLI, you can use it on Linux or even your command line, or you could use PowerShell to also automate resources on Azure. So, but the problem with PowerShell is vendor, not vendor neutral. It is fixed to a vendor. You could only use it on Microsoft's Windows operating system. But if you learn Azure CLI from the command line, you could use it on Windows machines. You could use it on Linux machines as well. Yeah. So the way I would like to see is you should never be locked with. Though we are learning Azure, maybe you are a company that runs on Linux operating system. So why do you just want to be tied up with PowerShell? But the Azure command line will work in both PowerShell, in both Windows command line and also in Linux shell. So these are two different approaches. You can use PowerShell or you can use Azure command line. Again, it depends from organization to organizations, but as I said, Linux is most predominantly used operating system.
Are we going to discuss about the TFS or VSTS also?
Yeah, the VSTS is renamed as Azure DevOps.
Okay.
Yeah, I did not include that not to confuse people, but I mentioned somewhere, just a second. Yeah, when I said Azure DevOps, this is actually your TFS, sorry. That was traditionally called TFS. Now it's called VSTS. Okay.
Mhm. So being a .NET developer, I'm a .NET developer. So our course is about Java. So can I easily, for practicing, can I easily upgrade to .NET? Like we in Java, we need to install the Apache using Terraform, right? So in the same
Yeah,
way, can I use the same thing?
yeah. You can
I,
similarly use IIS for your Windows servers. So if you know the approach and the right modules to use, you could configure IIS similarly with your Apache.
Mm.
Yeah,
so
honestly, I haven't done much automation with the Windows side. Mostly it was on Linux side,
okay.
but we could definitely give it a try. Yeah, you may practice and also teach me.
Okay. So all these are available. I mean, the material all are available in the Azure things. I mean, Azure website.
So Azure portal you'll use to create resources, but again to deploy sources, to deploy software, for example, you will take one of the Azure machines and install on other Azure machines. So you will use it as a master machine and you'll deploy into it on other servers. So these are all open source tools. For example, Ansible is an open source tool. Terraform is an open source tool. You will write code on your own machine and push it to your GitHub or VSTS, and from there your machines can pick up.
So all these tools are I mean, pre-installed in the servers, or we need to install it. I mean,
No,
like
we need to install. Yeah, we need to
okay,
install. Yeah, so that if everything is pre-installed, maybe we'll not have DevOps roles itself.
okay.
Yeah. So we also learn how to install and how to configure them.
Hmm.
Hello.
Yeah.
Hello. May I know virtual instance is in a virtual machine?
Yep.
Yeah. What I did, I installed my code in virtual machine.
Okay.
Okay. Okay. After that,
Okay.
I am connecting to Azure DevOps. That is the right way approach.
No, no, no. That's not the right approach. You install uh, a software like a web server on your instance, then
Okay.
you make the deployment automatic through your Azure DevOps. So every time you need to,
Okay.
so for example, you developed a simple Hello World program. Okay.
Yeah.
So
Okay.
you first create an Apache server on your Azure virtual machine. Then
Okay.
you use Azure DevOps to push this code onto your virtual machine. That's first part. Later, you want
Okay.
to make some changes to your code, like hello world, this is so and so. Okay, this is my name.
Uh,
You want to add this line.
yeah.
Then you add your line on your own computer. You push the code to
Uh,
your Azure DevOps source code repository. From there,
hmm.
okay, it
uh,
should automatically,
okay. Remotely trigger.
yeah, it should remotely trigger
Yeah.
and take the code. The server should remotely take the code and automatically update your web page. That's the way things are
Okay.
done.
My question is, at Azure, AWS, AWS code deploy option is there.
Yeah, yeah.
Yeah. Code
So that's
deploy. It will.
mhm.
It will automate the without downtime. It will automate the code. When I
Right.
apply
Yeah,
something, it will
yeah,
automatically trigger and it automatically install new instances.
yeah, yeah.
Yeah, I read one document in Google. They are
Mhm.
saying code deploy is similar with Azure DevOps.
Correct. Yeah, it's one part of your Azure DevOps. They have something called as code commit. So Azure DevOps is combination of three, four tools. Like you have a source code
Okay.
repository. Like yeah,
Git.
it also has its own CI/CD. It has its own GitHub. Okay, it has its own
Yeah.
ticketing tool. Yeah, this is combination. Azure DevOps is combination of multiple tools. It's a platform in
Okay.
the way.
Okay. My question is how we will use CI/CD with my code Azure CI/CD.
So you set up a pipeline on your Azure DevOps. Okay,
Okay.
you will
Okay.
give, if you are using GitHub, you could still use your Azure
Yeah.
DevOps to connect to your GitHub. Okay, if you're using your
Yes.
own Azure DevOps code repository, you will
Uh,
build an item, a pipeline where you will give all the details. Okay, take code from here.
okay.
Okay, use these
Okay.
tools like Maven or NuGet or whatever and build the code. And then once the
Okay.
code is built, take this code and this is my server where it needs to be built. This is the authentication. Please deploy it there. This is a pipeline.
Okay. Directly I will give authentication rules and I will directly target where I need to deploy.
Yeah, you have
Means
various
it
methods
needs
of
to.
authentication. You could use SSH keys. Okay, it depends upon what
Okay.
sort of authentication and what
Username,
sort of
password
thing.
also.
Yeah, you could use some managed identities. Okay, you
Okay.
don't want to mention them in plain text for security reasons. Maybe in learning you could do
Okay.
that to learn, but yeah, there are other methods to do that.
Okay. First, your answer is whatever I need to deploy. First, I need to commit code and I need to integrate with Azure DevOps. Then only I will give target to virtual mission or anything, right?
Yeah, I mean, when you say Azure DevOps, it also has its own source code repository. First, you push the code to
Yeah.
source code repository. Yeah,
Okay.
from there to
First,
your integration server. Yeah,
first step is Azure DevOps. Then only we will target give into virtual mission through the
correct.
Azure
That's right.
DevOps.
Correct.
Yeah. Thank you so much. Yeah. Go ahead.
Yeah, yeah, that's it from my end. Anyone else has any other questions?
Kiran, I have one question on Kubernetes or
Sure.
Docker. Whatever
Hmm.
in the session that you are going to cover, is it something that
Hmm.
you are going to create Docker image and then you create like Docker file and build it and then you
Yeah,
push it to through Kubernetes?
yeah. So first we'll learn about Docker. Maybe you know some bit of containers, but others might not know. So we'll understand what container is, what is a Docker image, how do we build Docker containers, or how do we build Docker images from a Docker file, how do we run Docker containers, how do we stop, how do we start, all this part. So then that's one part. Then how do we orchestrate this? If you're running an application on Kubernetes, how do you deploy multiple services? How do you create deployment? How do you create a replica set? Okay, how do you create authentication. So we'll do that, and we'll create a cluster on AKS. Is
Okay.
that
Do
clear?
you cover Jenkins also?
No, because we're touching Azure DevOps. I think it would be repetitive, like touching two CI/CD topics.
Okay.
Yeah, I would rather prefer Jenkins rather than Azure DevOps because it's an open source tool. But this course is primarily Azure and DevOps, like Microsoft oriented. But yeah,
Okay. And like, I think I like your demo session, to be frank.
yeah. Thanks.
Thank you for the details.
Yeah. Any other questions?
Yes. So the Azure is free for 1 month, right? 1 month subscription.
Yes, yes,
So,
yes.
so what is going to be charged after 1 month? How much amount it's going to be? Like the limitation is
So it
okay.
will
Yeah.
yeah, it will turn it as it will be converted into pay as you go model, meaning as many resource. I mean, if you're creating virtual machine for 2 hours, you will be charged for 2 hours. That's the model of cloud, right? So if you're creating AKS cluster for 30 minutes, you'll be charged for the 30 minutes.
Okay. Comparable to AWS, is it more chargeable than in Azure?
It
AWS.
depends.
Yeah.
I mean, I myself have tried to understand the pricing model. Uh, Microsoft claims on their own portal that they are 5 times cheaper than AWS when it comes to Windows instances. But for Linux instances, I think AWS is slightly cheaper. And I think Azure also has a very, in the sense of billing, Azure charges per minute. So that's one difference. Um, yeah,
Okay.
and to your question, if you're worried about what will happen after 1 month, we all have different email addresses. We have our brothers, so we can ask them
Yeah.
to create an account for us. Or
Okay.
if you're working in a large organization where Microsoft is your primary vendor, some of you people might have Visual Studio subscription, okay, which will give you
Yes.
some amount of credits every month. So you can check with your organization or your friends working in Microsoft, bug them. I need free Microsoft subscription. So there is something called as Visual Studio subscription, which will give you some amount of Azure portal access every month, like 5,000 rupees or something. It depends on organization to organization, but if your company has Microsoft subscription, ask them, do we get Visual Studio subscription? That will give you free Azure portal access. Okay. For
Actually, I
example,
have
I will.
portal access, but I don't know how. I mean, if I use anything, I'm worried about if it is charged like that.
So what is the subscription called? Is it called pay as you go, or what does it say? Free tier?
I think it's 1 month. I think I don't remember. I need to check it again.
Yeah. So if you think if you have created long back, just make sure you have no resources on it. Delete your account or just stop using it and create a new account with new email ID. It will ask for your PAN card, I guess. Not sure, but you can give any dummy values. It's not validated. So maybe you can create a uh,
Credit
new account. And also,
credit
yeah,
card is
as I said,
mandatory.
credit card is not mandatory for Azure. I think debit card also works. That's
No.
mandatory for AW. Oh, yeah. Sorry. Yeah, I'm talking the other way around. Yeah. Azure credit card is mandatory. Yeah. You'll need to use a different credit card.
Yeah.
Yeah. Or else try with your friends, your organization, check if anyone has Visual Studio subscription. For example, I'm using my friend's subscription, which is a free subscription for them from their company point of view. Okay. So, yeah, just
Okay.
try that part or use a different credit card, use your friends, okay, spouses, anyone's credit card, and create a new one. Not today, maybe on Monday or Tuesday, because that will give you additional 2 days. Okay. Yeah, that's true. Azure actually asks for credit card, and last session, some of the people had issues. Yeah, so you should be little careful there. I mean, there will be no, automatic billing. You will have to pay for that, but yeah, just be careful. Anything else, guys?
No, no, go ahead.
All right, I think that's about it from my end. Hopefully, we'll meet again Monday. Okay.
Kiran, may I know what's the difference between like PowerShell and ALI?
CLI, command line interface.
You are saying that like
Azure CLI.
you are going to
Yeah,
CLA, sorry, CLA.
yeah, CLI. So when any cloud provider builds their tools, they will give you some modules or some software tools. Like you could use also Java to automate your Azure resources, or you could access your Azure resources using Java or even Ruby. But similarly, they have a module in Azure. Okay, sorry, PowerShell. You could just import one PowerShell module and you start using, like, instead of get list or whatever you call in PowerShell, you could use get Azure VM, give my list of VMs. Okay, or you have another way, which is Azure CLI, command line interface. So PowerShell can be only used in Windows, right? But
Okay, okay,
Azure Azure CLI is operating system neutral, operating system agnostic. You can use in your Windows, you can use in your Mac OS, you can use in your let's say Linux systems as well.
okay,
Yeah. So we can do a lot of automation using PowerShell, but I would rather prefer Terraform to do that. Okay. So Terraform, when you learn
okay,
PowerShell,
okay,
it is again specific to Windows, and PowerShell is, in my opinion, is not as flexible. Yeah,
okay,
but you can definitely learn PowerShell commands on your own, PowerShell Azure commands on your own. Okay, that's not a big deal.
okay, okay, okay. Thank you, Kiran.
Yeah, you're welcome. All right, folks. Then hopefully see you all on Monday. Bye bye. Have a good weekend.
Yeah, thanks. Bye.
Bye bye.
Yeah, thank you. Thank you.